Hey guys, in this video I'm going to be going over polynomial long division and its applications on the SAT. So first, if you're unfamiliar with how to do polynomial long division, don't be too worried. It's very similar to normal division, but you have variables. So let's look at an example. So if we have 3x plus 7 being divided into 6x cubed plus 20x squared plus 5x minus 21. And the process that you undergo is pretty much identical to long division. You say, well, in this case, you should look at your leading term, in this case 3x, whatever has the highest degree, and look at your first number here and think, what number must I multiply to 3x to get a result of 6x cubed? And that answer is 2x squared. Right? And now I take this number and I multiply it to both terms of my divisor polynomial, and I'll get 6x cubed plus 14x squared. And now I'll subtract, and I'll be left with, of course, these will cancel out, 6x squared. And now I look and I say, well, what do I need to multiply by 3x to get my 6x squared? And the answer is 2x. So now when I multiply that, I'll get 6x squared plus 14x. And now I want to subtract that, and I'll take this 5x down so it's easier to see from my next term. So I'm subtracting. As always, these first terms will cancel out, and we're left with 5x minus 14x, which is simply negative 9x minus 21, which I'm bringing down. And now, what do I need to multiply by 3x to get negative 9x? And the answer is simply negative 3. Negative 9x minus 21. And in this case, both of these will cancel out. So that means we have a nice even answer of 2x squared plus 2x minus 3. Now, let's look at an example of how this might be used on the SAT. Here we have a question from an actual test. And we are given 3x squared minus 4x plus 2 over x plus 3. And we want to find what it's equivalent to, including this a over x plus 3 part. Well, we can use polynomial long division. So, as a fraction, we're essentially just saying that we're dividing this top term by this bottom term. So that's what I'm going to write out. X plus 3 divided into 3x squared minus 4x plus 2. And if you ever see on an SAT problem where you have a fraction with polynomials and it's equal to something in this form where you have an x term, a non-x term, and then something over whatever the same divisor is this side, then you're going to want to do polynomial long division. So let's look. We're going to multiply by 3x and get 3x squared plus 9x. Right? Same process. 3x squareds will cancel out. We get negative 4x minus 9x to get negative 13x. Bring down the 2. What do I need to multiply my leading term by to get negative 13x? Well, it's just negative 13. So now I get minus negative 13x minus 39. And now, when I subtract negative 39, I'm adding 39, so I get 41. And now, there's nothing I can multiply by 41, or no nice even number that I can multiply by 41, or I can multiply by x to get 41, excuse me. So I'm going to need a fraction. So whenever you have this leftover number and you're not really sure what to do with it, it's always a very simple rule. You take this number, and this becomes your remainder. And how do I write that up here? Well, you just take your remainder, and you divide by whatever your original divisor was. Simple as that. That'll work no matter 100% of the time. Whenever you get to your final term, if there's no x in it, just put it over your divisor, and that'll give you your last term or your remainder. So in this case, we can very easily see what the value of a is because we have our 3x minus 13 here, or 3x minus 13 here, and our a over x plus 3 is the same as our 41 over x plus 3. Therefore, we know that a must equal 41. And that's it for this video.